Did you know that Pluto is not just a cold and dark ball of ice? The surface of this dwarf planet is covered with frozen nitrogen, methane, and carbon dioxide due to the extremely cold temperatures. Despite this, Pluto has a diverse and dynamic surface, with features like mountains, valleys, and craters, and even red snow. The most iconic feature is a heart-shaped glacier that's the size of Texas and Oklahoma combined. But how can a planet so far from the sun have such complex features? Pluto orbits the sun at an average distance of about 3.6 billion miles, which is roughly 40 times as far as Earth. As a result, it receives very little sunlight and heat. A year on Pluto lasts 248 Earth years, and a day on Pluto lasts about 6 Earth years. However, there are still many questions to be answered about this icy dwarf planet. How does its distance from the sun affect its temperature and atmosphere? What are its moons like? And how hot are its volcanoes? Let's find out. Pluto, our solar system's former ninth planet, has long piqued the interest of astronomers. Despite being discovered in 1930, we did not have the opportunity to explore this distant world until the launch of NASA's New Horizons space probe in 2006. Pluto's small size and distance from the sun make telescope observation difficult, which is why New Horizons was such a game changer. On July 14, 2015, the spacecraft made its closest approach to Pluto after traveling over 3 billion miles. New Horizons was able to capture high-resolution images of Pluto's surface during the flyby, revealing a world full of wonder and surprises. Pluto's heart-shaped region, known as Tombaugh Regio, is one of the most notable features, named after Pluto's discoverer, Clyde Tombaugh. This area is thought to be a basin formed by an ancient impact that has since filled with nitrogen ice. The New Horizons spacecraft captured stunning images of Pluto's surface, revealing ice mountains, nitrogen glaciers, cryovolcanoes, and canyons. It was an otherworldly landscape that surpassed our wildest expectations. And now we're here to show you some of its most incredible features. Let's start with the brass knuckles, a one-of-a-kind feature near Pluto's equator made up of 6 lowland regions called macula, each roughly the size of Iceland. These regions are linked by a network of canyons, each named after a different netherworld spirit from mythology. The dark color of the brass knuckles is due to tar, made of tholins, which are hydrocarbons formed by the interaction of methane and nitrogen with cosmic rays. Tholins are responsible for the red colors as well as the blue tint of the atmosphere of Pluto. Tholins can be found all over Pluto, including the nearby whale-shaped region known as Cthulhu Macula. The brass knuckles appear separate because each macula is separated by towering ice-covered uplands. These several kilometer-high uplands are most likely made of frozen nitrogen, methane, and carbon monoxide, on top of a bedrock of water ice. Nitrogen is the most abundant material on Pluto's surface, accounting for 98% of its total volume. It also contributes significantly to Pluto's most recognizable feature, the heart-shaped region known as Tombaugh Regio. The western lobe of the heart is a smooth basin filled with Sputnik Planitia, a nitrogen ice plain, whereas the eastern lobe is much rougher. Sputnik Planitia is a vast nitrogen ice plain covering about 1,000 kilometers, making it one of the solar system's largest known glaciers. Scientists have been perplexed by its smooth surface, which is almost devoid of craters. This suggests that the basin is young, possibly formed by a recent impact or by volcanic activity. There are, however, other theories about how Sputnik Planitia came to be. According to one theory, the basin was formed by a large impact that fractured and deformed Pluto's icy crust, resulting in the distinctive wrinkled edges visible on the surface of Sputnik Planitia. Another possibility is that the basin was formed by a cryovolcanic eruption in which water, nitrogen, and other volatile compounds erupted from Pluto's interior and flooded the surface. It has a unique topography. The basin is in a region of Pluto's surface dominated by the Tenzing Montes, a large mountain range. The basin is also tilted at an angle of about 30 degrees to Pluto's spin axis, implying that it was formed by a massive impact that caused the planet's axis of rotation to shift. But that's not the only thing to see on Pluto. New Horizons also photographed the Right Mons cryovolcano. Unlike the fiery volcanoes we're used to seeing on Earth, cryovolcanoes are known as cold volcanoes, which are made of materials like water, ammonia, and methane, which can remain liquid at much lower temperatures than molten rock. The right Mons is over 3 kilometers tall and 150 kilometers wide, making it one of the solar system's largest known cryovolcanoes. Scientists believe that the volcano is still active, spewing a mixture of frozen gases and liquids into Pluto's thin atmosphere. While Pluto's temperature is much colder than any place on Earth, recent studies suggest that the dwarf planet might be experiencing a form of global warming due to changes in its thickening atmosphere caused by seasonal tilt. This phenomenon offers a potential explanation for the planet's warming surface temperature, which is as high as -375 to -400 degrees Fahrenheit. The geological features on Pluto, including Tataris dorsa, provide important clues to the planet's history. Scientists believe that tectonic activity caused by the expansion and contraction of water ice in Pluto's subsurface ocean has created the hills and valleys on the planet's surface. This subsurface ocean, located beneath a layer of solid ice, has likely influenced Pluto's geology and may have played a significant role in shaping its landscape. Charon, Pluto's largest moon, is full of surprises. Charon is so big that Pluto and Charon orbit each other like a double planet. Serenity Chasma, the moon's massive canyon system, is 4 times the length of the Grand Canyon on Earth. The canyon system is thought to have formed as Charon's interior cooled and contracted, cracking and fracturing its surface. The Vulcan Planum, a massive mountain range on Charon, is over 8 kilometers tall and 150 kilometers wide. One of the most remarkable features of Pluto is the Al Idrisi Montez mountain range, located on the western side of Sputnik Planitia. The Al Idrisi Montez mountain range is notable not only for its towering peaks, but also for the remarkable field of transverse dunes that surround it. These dunes, made of methane ice particles, form in sub-zero temperatures, making life as we know it impossible. It's incredible to think that nature can create something so breathtakingly beautiful, even in such harsh conditions. What is even more incredible is how these dunes formed. Scientists believe that the methane particles are carried into the atmosphere by the sublimating nitrogen ice on Pluto's surface. The particles are then carried by the winds to the mountains, where they are deposited back onto the surface, forming the dunes field. But the Al Idrisi Montez mountain range has one more surprise in store for you. A deep trench on the western side of the mountains is visible as a dark blue band on a colorized elevation map. The trench adds a new level of complication to an already fascinating landscape. The peaks adjacent to the trench range from 200 meters to 1 kilometer, while the farthest peaks reach a staggering 3 kilometers. This means that as you move away from the trench, the mountains grow taller, similar to the Rocky Mountain. A fascinating 2019 study presented at the Lunar and Planetary Science Conference has revealed some intriguing findings about the mysterious Al Idrisi Mountains on Pluto. According to the study, these mountains have shifted eastward due to a process known as solid-state convection, which may have resulted in the formation of a deep trench on their eastern side, causing the peaks to rise in elevation from west to east. This movement, however, raises the possibility of a hidden layer of liquid water beneath Pluto's icy crust. But hold on, there's more. The research also sheds light on Picard Mons, a massive cryovolcano that stands 7 kilometers tall. Although the images obtained by the New Horizons spacecraft are not as clear as those obtained by other structures on Pluto, they reveal intriguing similarities to Earth's calderas. Furthermore, the concentric rings surrounding the depression suggest a series of eruptions, followed by magma retreat and subsequent vent collapse. We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.